Alright, we're going to look at the Fibonacci sequence, which is kind of interesting. Well, the simplest way to describe the Fibonacci sequence is as a series of numbers in which the next number in the sequence can be found by adding up the two numbers before it. So you get like 0 and 1 is 1, 1 and 1 is 2, 1 and 2 is 3, 2 and 3 is 5, 3 and 5 is 8, and so on. Picturing the squares here. This is where it kind of gets interesting when you actually get a picture of what's going on. But you have your first dimensional square, right? And then it takes two of those first dimensional squares, so your first two numbers in the series, to make your second dimensional square. And you can see how it lines up. And then you have your third dimensional square. And you can see how the area kind of adds up and fills itself in. But as you kind of move through the squares, you get this pattern. And when kind of drawn together, you get this spiral. And a lot of mathematicians and scientists have been interested in this spiral, and what's been known as the golden ratio, which we'll get to. But the spiral and the just the patterns that the Fibonacci series creates in this layout has interested a lot of scientists. And then that you see these observations in nature, which is one of the major interests, do these calculations have to do with nature? But when we talk about the golden ratio, if you start taking these numbers in a series and dividing these numbers, by dividing numbers within the Fibonacci sequence with previous numbers in the series, we get what has become as the golden ratio, and they call it phi. They use the Greek symbol phi to simulate this constant. But the larger the numbers get in the sequence when these divisions take place, the closer we get to this constant, and it's approximately 1.618. And it's kind of interesting if you really look, like at this graph I have pictured in the lower right corner. Like when you divide 2 by 1, you get 2. 3 by 2, you get 1.5. Then 5 divided by 3, you get 1.66. 8 divided by 5, you get 1.60. But how the numbers kind of fluctuate up, then back down, up, then back down, up, then back down, but they get closer and closer, and they just keep kind of diverging into this constant, which is very interesting. But also you can use this constant, this phi. You can use it to calculate any number in the series. So say you want to know x of n, we can use phi to calculate this number. So say we have x of n and to where n equals 6. Okay, that's going to give the sixth number in the Fibonacci sequence is 8. But if you take and you plug phi into this equation, it actually gives you 8. So that's another interesting twist. But let's look at some C programming. We're going to construct just a simple program to calculate the Fibonacci sequence. So let's do that. First I'm going to change directories into my programming directory and then into my C programming directory. Here I'm going to make a directory called Fibonacci. Change into that directory. And here I'm going to create a file. I'm going to use Vim as my text editor. I'm going to create a file called Fibonacci.c. Alright. I'll include the standard in-out header file. And we're also going to include the standard library header file. Well, let's put a title on this. This is a program to calculate the Fibonacci sequence. Alright. Let me go down further to try and keep my program in the center. Let's put in our return 0. Alright, we got to clear some variables. We got C will be for our cycles variable. The sequence. Oop. We'll have int. First, we'll actually set that equal to 0. And int second. And we'll set that equal to 1. And we're going to have int next. Okay, let's prompt the user for our end value. So print f. We'll say enter we'll say enter many numbers. Put a new line character. Enter how many numbers you'd like to calculate in the Fibonacci sequence. Alright, now we're going to scan F to get some information from the keyboard about our user input. And here we need the address of and the end variable. Okay. Now I'm going to set a few conditionals, all revolving kind of around one. We're going to say if n is equal to 1, first number use the exit statement. Okay. Now we're going to say if n, we'll say if n is less than 1. So let me get in the middle of the screen. If n is greater than 1, okay, I'm going to have it print second because our for loop isn't going to print the first number in the series. So, and I forgot to add our n here. Okay, so we're going to have a for loop, and here we're actually going to say we're going to set c equal to 1. Then we're going to say if c is less than n, then we'll increment c, so c++. Then we'll go ahead and set our loop. There was one more conditional here. I'm just going to go ahead and put if. Yeah, we'll put if and we'll say is less than 1. Oh. I wonder why that didn't look right. Okay. I'm actually gonna. Okay, so we want to say next, equals first plus second, right? And after that, after we add first and second together, second will become our new first, if that makes sense. And just like second becoming our new first, next will become our new second. Yeah. And then we are going to do another print F. And this is going to be our next. Just clean some of this up. Let me try and compile it, see what happens. Alright, so GCC, we'll say dash O for our out file, and that looks good. Let's try and run it with our conditionals. Enter how many numbers you'd like to calculate. Let's see what 0 says. This is an invalid number. Okay, good. Minus 9. Okay, let's just do 3. Okay, these are the first. Okay, 1 was one of our conditionals too. First number in the. Okay. Let's just take it. I'll put less than that so they fit on the screen. See if that. There you go. These are the first 30 numbers in the Fibonacci sequence. All right.
But you can't see me anymore. You're not behind the time.